All right, welcome to another episode of Chain of Thought, our podcast on all things Scale AI research. On today's episode, we're going to dive deep into some of Scale's latest research on coding agent benchmarks and evaluations. My name is Brad Kenstler. I'm the head of agent capabilities and environments here at Scale AI.
I'm Jeff. I'm a scientist on agents.
Hi, my name's Edwin, product manager on coding agents.
I'm Chetan. I lead the product team for agents and environments. And we're really excited to share some of the latest research that this team has been working on. Before we dive into the new benchmark and all of the research that came out, I want to talk a little bit about coding agents. I think coding has really emerged as one of the killer use cases for models, and for quite some time now they've produced a lot of value for developers. And you see these coding agent tools everywhere. You have a lot of different types of tools as well. Do you mind telling us a little bit more about how these coding agents actually work under the hood?
Yeah, totally. Coding agents, like any agent, governed by the same action observation loop that you'd expect. The key differences here being that your actions are largely functions like, open a file, read the contents, maybe like parsing some of the output from executing a command. And then your action, is that your actions? Sorry. Yeah. So your observations would be things like the actual output of the file or the output of a command, something like that. There's a whole ecosystem of these harnesses that have been produced to parse all of this context and feed them to the LLMs. And so I think largely that's how that would look under the hood.
Yeah, absolutely. And I think, on the research side, and when you think about like how these agents are designed from a technical perspective, I think they follow a very similar model where you have an agent with an environment, a set of tools and actions that it can take. On the product end, I think we're seeing a lot of different types of agents come out. You know, like the agents that are used for vibe coding, like the Lovables or the V0 sort of agents. Then you also have more autonomous coding agents like Cognition or Codex, and then you also have agents that are really embedded within IDEs like Cursor and Windsurf. Can you tell us a little bit more about some of the key differences between these agents? Your own thoughts on this larger ecosystem and where value is kind of being created for users.
Yeah, I think as you mentioned, a lot of the underlying model is the same. So GPT-5 or Claude will power all of these agents. And then the main difference is in the scaffold or the UI or the types of prompts that they use. You mentioned a whole spectrum. So on one side, you have Cursor, which is a little bit more of human augmentation. So it's aimed at someone who, for example, is in an IDE like VS Code. And then you have them use the agent alongside the coding day-by-day tasks. Then in the middle, or for a different use case, you have something like Codex or Cloud Code that's a little bit more autonomous. So then you expect the agent to be able to complete a series of tasks end-to-end with a little bit of interaction, but maybe a bit less. And then you also have, as you mentioned, maybe a bit more of vibe coding. So in this case, the user might not have as much familiarity with the underlying code, and then they would have less control over the implementation details, and then that way the agent would take care of it instead.
And so in each of these examples you gave, and also just in terms of how we think about coding agents in general, you have this model, right? And it's what is it interacting with, right? Say if I'm using Claude Code or Cursor, am I working in a code base and there's an agent that's interacting with that code base?
Yeah, for Claude Code, it would be a code base. I think there's kind of two things. So one is tool use, which agents have gotten a lot better at. So a lot of the reasons why these agents are successful is because they can successfully execute tools nowadays. So for Claude Code, that would be something in your terminal. It might run a series of tests, or it might try out a patch to solve your task. And then you also have potentially an environment. So that could be a code base, or it could be something more complicated like a Docker container. And in this case, the agent would follow this action interaction or action observation loop where the agent interacts with the environment, gets some type of feedback, and then uses that to iterate on its task.
I think one interesting question I think about is so obviously we laid the landscape for all these different coding agent products, right? Is what makes, a Cognition or a Claude Code fundamentally different than, let's say, a Lovable? Is that does that lie more in the scaffolding, or is it, the kinds of like data that are fed in, into like the training process for the underlying models, and the ways that that these agents are kind of like optimized to go after different types of problems?
Yeah, I think what's interesting is that a lot of the models and the training is the same. So, for example, when these models are trained, for example, with end-to-end RL, they're not exactly trained to be, for example, like for a vibe coding use case. But you take the base model and you might add some prompt, and then it's adapted for this use case. So these models are pretty general. They can do a variety of tasks, and it's more of like how you use the model in terms of the scaffold, the UI, or the prompt that enables the model to become these types of agents.
Yeah, I feel like it's pretty remarkable, like how much like values being unlocked in the application layer alone, right? Like if you look at, Cursor, Windsurf, Lovable, right? Part of what goes into the scaffolding that we're talking about is like figuring out what's the best way to represent the context of this code base to the model to enable it to make like really informed decisions about what tools to use. And so it's not like just starting from scratch every time. And I think it's been pretty interesting. I mean, this is, I think nowadays we call context engineering, right? Like figuring out what's the best way to essentially package up an entire code base or representations of a code base into a model's context window, so that way every time the model is performing some kind of task, it has some like latent knowledge of the code base and like isn't just starting from scratch every single time. I think the other interesting trend that we've seen is like, the players in the application layer that aren't model builders. So like, your Cursor, Cognition, right? They've obviously, I think, leapt ahead in the market. And then now all the model builders have entered, right? And so you have, Claude Code, obviously, I think is the most, the one with the most traction right now. And then, of course, Codex. We have Jules from DeepMind. And I do think it's interesting, like, do you guys think that now that the model builders have entered, like, will they be able to fine tune their models to favor like their specific implementations in their applications, like the tools that say Jules uses or Claude Code uses? Or do you think that like the way that these models are trained are so generalizable that it's not going to really result in that kind of performance gains for the model provider scaffolding? That's kind of a loaded question, but I think it's an interesting one.
Yeah, I think it's a huge advantage that something like Anthropic has with Claude Code or OpenAI has with Codex, in that they kind of solve this end-to-end training pipeline, and they also have control over how the model is being used and what scaffold is being used. And then they can use that, generate trajectories, for example, with real data or like real patterns that they see from the end user, and then improve the model end to end. And I think that's part of why these models have gotten a lot better over the last few months, is because they've kind of solved this end-to-end training loop.
They got a feedback loop.
Exactly.
Yeah. That's interesting. So yeah, I mean, like obviously over the past year, this has just been a red hot space. And like as we mentioned, the labs themselves have entered into the market. I'm curious from your perspective, like what makes coding agents such a priority to the labs, right? Because like arguably they can theoretically enter into any specific agent domain, right? But there seems to be a lot of focus on coding agents.
Yeah, I think from my perspective, coding is one of those skills that's largely been very gate-kept. Like it's very difficult to learn from a human perspective how to code. And then just like in general, coding as a medium is like the way that humans in general communicate to machines, configure them to do what we want, retarget them to interesting economic purposes. So getting coding out of the hands of a select few and into like broadly just like anybody who can speak natural language and define intent is a hugely valuable proposition.
I love that. That's like the democratization of coding.
Yeah.
By way of coding agents.
Yeah. And yeah. So for someone like me, or I might speak about it too, like who knows how to code from like pre-GPT days or something, I do see sort of this like up leveling in a sense of like how much time I save in things. And so like often I'm not writing really like individual scripts anymore. I'm like writing, hey, I need like some data from a script or like from a JSON or something, and like that just kind of happens, and it's really beautiful.
I think it's also very advantageous as a use case because you almost always have a human in the loop, right? And I think the ultimate vision for coding doesn't necessarily, need to match the state at which these agents are at today, right? Where, we can't necessarily trust them to like, take on large chunks of work or to, edit multiple files simultaneously and, produce production quality code. But we can trust them to, automate a lot of the work around, scoping out where there might be issues in the code base or answering questions about that. And you still have an expert in the loop, and you can enable that expert to do a lot of other things, right? Like make, product decisions, prototype very quickly. This enables go-to-market teams also. And so the people that get value out of the improvements that we see on the coding agent side span far beyond just engineers, and I think that kind of economic impact is very rare to see in such a short amount of time, and I think that sort of development cycle is just going to continue.
If the end result of progress in coding agents is enabling go-to-market teams to build their own products, then we might have to stop progress now. No, I'm just kidding. No, but that's exciting. I think the main point is that, like, look, it's lowering the barriers for non-technical people or even semi-technical people to code things quickly. Right. And like for consumers, that's been like really exciting. Like, you see tons of examples on like X every day of people building their own like choose your own adventure games, right? That they can like play in a web browser. Or like, even going back to what we were just joking about, like it really is an advantage for like, non-technical PMs or like go-to-market folks to like be able to quickly sketch up mock applications of things pretty quickly and like use that to demonstrate things to customers and stuff like that, and really just have a closer feedback loop between customers and like end users and like the actual creators of these applications. So that's pretty exciting. I'm curious, like, what do you guys use coding agents for in your day-to-day work?
Do you want to start?
Yeah. So I think one thing that I did pretty recently is the work on the paper for SWE-Bench Pro. And then there are a lot of graphs, which are entirely agent done. So there's like a 1,000 line script that I haven't read most of it. But I think, Claude or ChatGPT can make much better graphs than I can. So that's been pretty helpful.
For me, I make a lot of figures. And one of the things I love to do with figures is remove the background. I don't know if anyone's tried to use like online tools for removing backgrounds. Kind of mixed.
Like for SVGs?
Yeah. Or like take a PNG, like it's like white background. Remove the whole thing. Yeah, okay.
Yeah.
So I threw it in GPT months and months ago to like kind of get like something working here. I thought it would just give me like I was hoping it would just give me the return without it. What it ended up doing was actually like writing a script that it would run. And I was like, oh shit. So I started like iterating on the script. And now between GPT and we have probably the world's best background remover. And I'm not sharing with anyone. So I've been sending every figure actually internally I've made for this company has gone through that. And it's purely just because of coincidence that there's this random script living somewhere between GPT and I. So
you should commercialize it.
I think that the value prop is actually gone from that. In that, I think everyone really ought to be having some similar version of some flow codified inside of either, it doesn't have to be GPT, it's like something, right? But it's something you've arrived at that meaningfully optimizes a portion of your life. And then is accessible by just dropping a PNG into GPT and just saying, and another one, which is my entire conversation history with this thing since March. So, yeah.
Yeah, very cool. I think for me, it has to be the artifacts. I think, Claude Artifacts has been a very widely used feature in my workflow. I think it's very cool to, be able to spin up, prototypes or even just concepts of, designs without, needing the classic pipeline of scoping something out, sending it over to a designer, and then creating a version of it, and then having engineering actually figure out how to build it. And I think you can move so much faster. You can really evaluate multiple product directions at once. And this is just one of many things that coding agents can do.
Yeah, no, I'd say for me, definitely just prototyping. I find that using a coding agent is really great for just I have an idea in my head. I want to quickly build it and just test it out. And it's interesting how the complexity of what I can build quickly just increases over time. So like I'll give a recent example. So I was interested a while back in like basically evaluating how effective a browser agent can be as a verifier for like coding agents, right? So you have coding agents so this is getting kind of circular now, but you have coding agents, right, that are building websites. And so I wanted to figure out, okay, verifiers for front end is kind of difficult because oftentimes what you really want to test is like, hey, did a coding agent make a website that works, right? It has like all the user flows that you would expect, which isn't something that's easy to codify in predefined unit tests in the same way as you might have for like backend code. And so what I wanted to do is like make a browser agent that can basically like you give it a set of workflows. And each of these workflows is like kind of the browser agent equivalent of like a rubric or something. And then have it attempt to do that workflow on a website. Anyways, long story short, I basically use a coding agent to build this browser agent tool using Playwright and some other libraries, like in maybe just a few hours. So, this is something that probably would have taken me a few days, if not longer, like some time ago. And so it's like stuff like that, where it's like, I have an idea in my head, I want to test it out, and I can just do it super quickly without having to master Playwright or something like that. Using coding agents to create browser agents that evaluate coding agents is kind of a circular story there, but cool.
Yeah, very meta indeed. I think there's actually a space around that, like end-to-end automation, and there's so many opportunities, I think, around coding, and that's what makes it very attractive for both labs and application developers. So this is very cool, just talking about the overall landscape. Let's dive a bit deeper into the research. I think one thing we like to cover in these podcasts is how do we actually measure how good these models are at things like coding today. Do you mind walking us through some of the existing benchmarks? Like, what are people doing to actually evaluate coding agent capabilities?
Yeah, I can talk about some of them. So there's a bit more general coding benchmarks. So for general coding, which is a little bit more adapted, there's competition style code. So you might see something like IOI or MBPP, mostly basic Python problems, or human eval, which is all competition style coding problems or leak code problems, which is a little bit more of general coding ability. And then for agents, there are a couple of benchmarks. So one is SWE-Bench, which SWE-Bench Pro is inspired from. And then in this benchmark, you have the problem statement, but it also comes with an environment and then a set of tests. So these are a little bit more realistic. You try to see if the agent can solve this task autonomously, end to end, and then execute tasks in the environment to verify if it solved it. And then there's other types of benchmarks that are pretty similar. So I'll give one example, which is terminal bench. So in this one, you have a CLI agent, and it might execute some commands. For example, it might say run, like maybe it might be like create this file and then change the permissions on the file to be this. Then you have some verifier. And that's a different type of coding that people might do, which is tested in this benchmark.
So one thing you mentioned was like general coding versus like agentic coding. Can you just like explain like to the listener, like how do these things differ?
Yeah, I think like one key is that with benchmarks, I think we started with what was the easiest to create and verify. So yeah, I guess like one thing for benchmarks is that you want it to be correct. So you create the most straightforward benchmarks first. So that's a little bit more general. And then a lot of these general coding benchmarks that I described are what you would see in kind of like maybe like algorithmic coding. So something like leak code. And then for something like agentic coding, you have a little bit different of a structure. So for agentic coding, you generally have the problem, but then it also comes with an environment and potentially a set of verifiers. And then all of these are used to create a end-to-end problem that's used to test the agent.
So it's like a general coding is like you give the model all the context when you evaluate it against something. So like it might be like, here's some like problem, or like here's some existing code, and you like have like the code snippet, and then you tell the model, I want you to improve it by doing this way, or I want you to implement something else, and the model spits something out, and then you basically evaluate that. Is that kind of the idea? Yeah. And so then the agentic version is like, you don't really give the model's context is the environment, right? And so it's like you ask questions, you give the model tasks, and it has to like interact with that environment. And so like what are some of the like what goes into that? Like what makes that more difficult than like a general coding task?
Yeah, I think there's a couple of things. So the hardest one is the fact that the task happens over a very long context or many turns. So to successfully solve a agentic coding task in something like SWE-Bench or SWE-Bench Pro, the model needs to interact with the environment and then get feedback and then act on that feedback and improve. So what you might see is that at the beginning, the model will do some type of planning. So for the first 5 or 6 turns, it'll try to plan and scope out the code base. Next, it'll try to find which files are needed to solve the task to add it to its context. And then it will create an example solution or a patch, and it will try to solve the problem. So for SWE-Bench, that looks like some type of PR, which edits a couple of files to solve a set of tests. And then usually it goes through some type of verification. So it'll run its own test to make sure that the solution that it tried or created works. So the model has to do all of this. So that's one of the larger challenges with autonomous agent benchmarks.
So my understanding here is that for the coding agents, they actually have to use tools to like navigate through the environment to figure out how to accomplish the task. And so you might have multiple tool calls, in one larger trajectory to get to that final answer. And there's a lot more room for error. Whereas, for general coding agents, and it's not like either of these are perfect yet, but you're kind of transforming input tokens directly into output tokens. And so I think a lot of the tasks that benchmarks evaluate these general coding agents are smaller in nature. The context is a lot smaller as well. And so I think the overall action space, for coding agents is bigger. And I think that's what makes it exciting, because real engineers, live in code bases and repositories, and they're not, always taking single files and trying to figure out how to, add some code or to refactor the algorithm, right? I think they're, working in very large code bases, oftentimes with many other engineers, and being able to replicate that reliably remains like one of the big unsolved challenges, and something that, we're definitely working towards here.
Yeah, it's like the benchmark evolution mirrors sort of how we use LLMs for coding, right? Like, back in the day, the way that I would use LLMs was I'd basically just copy paste some code, just dump it into ChatGPT, ask a question, copy it out of that, put it into the code base, right? And that was like super clunky, like not really great. Dark times, right? Exactly. And now we have the delightful products like Claude Code, Cursor, and like Cursor Agent mode. And that now mirrors sort of the benchmarks, right, as well, because like you're evaluating their ability to interact with an actual code base.
Yeah. So prior to this new benchmark that we just launched, I think SWE-Bench has been the default way of evaluating how good coding agents actually are. So can you walk us through like how do models perform on SWE-Bench today? I think almost every single big LLM launch recently has reported their scores on SWE-Bench, and it has just been viewed as the ultimate test of coding problems. Our models answering these questions well? Do we think this is a good representation, of what real world coding looks like?
Yeah, I think SWE-Bench came out in 2023 or 2024. So when SWE-Bench came out, it was pretty difficult. So models got about 5%. And then now the best models are tested on the subset called SWE-Bench Verified, which is 500 problems that are human verified. So instead of like a more open subset, we only tested the ones that we know are correct. And then on this subset, the best models get about 70 to 75%. So yeah, a pretty big improvement. And then I think like the previous generation would get about 60%. So also very good.
How do you get from 5% to 70% plus in, less than 2 years?
Yeah, I actually think it's a couple of factors. So one is like obviously the models are better. So as we discussed before, labs care a bit more about coding these days because it's so widely used, and they have their own code products. I think one other big thing is that the scaffold got a lot better. So Yeah, like we have a more robust scaffold that we can use to evaluate these agents, and we have like many different types of scaffolds. So the scaffold is pretty similar to something like how you would use Codex or Cloud Code, just something that tells the agent to use tools and then enables a end-to-end loop. And yeah, these tools have gotten better and enabled the agent to perform a lot better on these types of tasks.
So correct me if I'm wrong, but we're in like the high 70s now on like task resolution rate on SWE-Bench, right? So like what does that mean? Like, are developers cooked, or like what is like what's going on?
I think that the representation inside of SWE-Bench Verified is pretty narrow. We're talking about like 12 repositories, 500 problems, all Python. I think like a lot of infrastructure out there that software developers are using it's not all Python. So there's definitely openings, and I don't think they're cooked yet.
Don't think they're cooked. Yeah, I mean, it's. I think SWE-Bench is. I mean, again, it set the standard, right? But like in terms of the distribution itself, like my understanding is tasks are more on the simple side, less lines edited, less like files edited, things like that than what you might expect like an average developer to be doing.
Mm-hmm.
I guess what I'm getting at is like the perception of SWE-Bench and like how. The media and community like react to progress on SWE-Bench. Oftentimes, people feel like, oh, if you're saturating on this, then like coding's been solved. But I don't think that's the case, right, Jeff?
Yeah, I think, I guess like in general, it's an eval, and then there are pros and cons to every eval. When SWE-Bench was created, the goal was to see if agents can solve a PR. Which I think it does. Like it does do that. Like it tests if agents can solve PRs, and then we can talk about the distribution on SWE-Bench. So the mode or the majority of the problems are one-line fixes. So I guess like many software engineers probably create PRs that are maybe 50 to 100 lines, and then versus you have about like maybe like 1 to 2 lines for SWE-Bench. And then, like Edwin mentioned, the repositories. So there's only a couple of repositories, and then the most common one, which is about a third, is Django. So if your model is like very good at this one repository, it'll do well on SWE-Bench. And then the last thing is the kinds of files that that are needed to solve the task. So most of the time, only one file will be needed. So the agent will just need to find the one file that's needed, then use that context to solve the task, versus probably you would expect, I guess, like as we know, like when you complete most coding tasks, you would need to look at a couple of files and maybe make a couple of edits to complete a PR.
Right. So in terms of like what SWE-Bench covers, again, it's at the standard, but it's somewhat narrow with respect to like languages, overall task complexity. So it's not like the end all be all of measuring coding agent capabilities. And we've seen, I think, some new similar benchmarks come out that look like SWE-Bench. There's been like multi-SWE-Bench, which I think has taken the same basic concept, expanding it into new languages. So I guess like with that, I'd love to jump into SWE-Bench Pro. And like, in case we haven't made this abundantly obvious to the audience, we're launching a new benchmark. It's called SWE-Bench Pro, and we're super excited about it. So I'm curious to learn a bit more about like what makes SWE-Bench Pro different, and like what were some of the big design choices around that?
Yeah.
Want to kick off?
Okay. So the biggest one will be obvious to anybody that's used the benchmark. The most obvious thing is that it's a lot more challenging. So one key about the challenge is that we wanted to make it challenging because software engineering is more difficult. So we wanted to make it more realistic. So what that means is that most of the edits will be about 50 to 100 lines. They'll cover several files. So the model will need to find 4 to 5 files on average to solve this type of task. And we also expect the model to have mastery over a set of repositories, and as you mentioned, also as a baseline or table stakes, also different coding languages. So Python, JavaScript, TypeScript, and Go. And Yeah, and then SWE-Bench Pro is also much larger. So we'll have about 2,000 instances and then 850 in a public set. And there's also some more differences with the types of repositories that we source. So one example is that we source from only GPL licensed repositories, which means that the model providers cannot train on this type of license, which helps with the data contamination issue. And then also to that front, we try to find repositories that are more realistic. So kind of like more like open source copies of B2B SaaS software. And then the last one is that we source repositories directly from startups, so commercial repositories. And these are contamination free, they're not public, and also quite challenging for the model.
So do we think that there's some degree of memorization around, benchmarks like SWE-Bench, just given the fact that these are open source repositories? There aren't too many of them either. You said there were only 12, and majority of the tasks are coming from one repo. Just want to double down on this contamination point because I think this is a very interesting topic. Is that what a lot of people speculate could be responsible also for models performing really well on SWE-Bench?
Yeah, I think there's kind of two things. So one is the data contamination. So probably most labs are not intentionally collecting trajectories from SWE-Bench test set, but it's just like pretty natural. Like for example, if you train on maybe like coding questions, you might have questions that are, or like Stack Overflow, you might just have questions that are on those repositories. And then two is kind of like the quote, which is that when a benchmark, I forget how the quote goes, but it's like when a benchmark becomes the measure of progress, it's not a good benchmark anymore. So I think SWE-Bench has kind of been good for the last maybe like 2 years. And then the goal is that SWE-Bench Pro will set us up for the future. So as agents become stronger, we can evaluate them on SWE-Bench Pro.
And so like some of the like ways that we're designing for decontamination, like I think you mentioned, are pretty interesting. So one is that all the open source repositories are effectively copyleft, right? Is that that correct? And so what that means is that hopefully the model providers haven't trained on those repositories, and if they did, like we might actually see that in the results, although that's not the intent of the data set, but or the benchmark rather. So again, like shouldn't be included in any of the training data. And then I think the second one is really interesting, which is like you talked about, we are sourcing code bases we're sourcing private code bases, right? So can you guys speak a bit more to that?
Yeah, so it's been a really fun endeavor. What we've gone and done is source startups that have since, for some time at least, like ceased operations. We've grabbed their code bases and gone through them to find similar sort of like SWE-Bench verified style problems that we can harvest from those repositories. We've then taken them and put them through the similar sort of process that we've used to source these, or to fix up the public ones. And then, yeah, this is now in the private set of SWE-Bench Pro.
Cool. So, I mean, decontamination by design can't get any better than that, right? Like these are code bases that no model provider has ever seen.
Hopefully not.
Hopefully not.
I would be surprised if they did.
I have some concerns. Yeah.
But
I think the other point of and the benefit of going after these private repositories is aside from the decontamination issue, you're getting real production code bases, and the way that developers at a startup write code is fundamentally very different than the sort of contributions you get in an open source repository, where maybe you have really strong contributor guidelines, you have a lot of standards for reviews, and that's very different than like the 5% startup that's still finding product market fit, or that 30-person company that is kind of optimizing their systems for scale. And I think there's so much valuable nuance captured in those different types of data distributions that haven't been used for either evals or training before. And I think these are just very interesting ideas that we're proposing at a very small scale right now. But I think this is going to drive quite a lot of improvement.
Yeah. On that note, I'm curious to double click a bit, Jeff. You talked a bit about like the repos themselves being looking a bit different than like the repos in SWE-Bench Verified. Like you mentioned, like these are more like open source implementations of like B2B SaaS tools and things like that. Can you maybe like expand on that difference a bit and like why is that meaningful?
Yeah, I think the goal is just to be challenging, but be also realistic in a way that we have tasks that would be closer to what you would expect a real software engineer to do. So we don't want kind of like in this benchmark, we don't want maybe like, for example, like competence in code or something that's like very difficult, but just not something that a software engineer would do. So I can give an example of one of the repositories, which is Proton Mail. It's a copy of like the Google suite of apps, so like mail, certs, those type of tasks. And so in that way, like it would be, for example, could be a bit closer to maybe what a engineer at Google would be doing if they were trying to build a feature for this type of task.
Cool. So we have like environment realism, really in two ways, it sounds like. So one is just that the open source repos we're sourcing, they're like, these B2B SaaS or similar kind of applications oriented. And then second, we have environments that are coming from private code bases. I'm curious, do you guys think that like private code bases, are they cleaner and more rigorous than the open source ones or not? Like, you might intuitively think, oh, if these are like production grade code bases, then, it's probably a cleaner environment for agents to operate in. But I've seen some production code bases that are very, very messy. So I'm kind of curious to get your guys' take.
I have a lot of anecdotal things here. Like they're pretty messy. The unit testing is often sparse, or at least like needs to be a little flushed out to make it more valuable. A lot of repositories, we'll often see like, oh, some company comes in and is like, oh, we got like hundreds of repositories in our code base, and like most of them are just like forks that no one ever like touched again, or like I've seen so many empty ones with just a readme.md. Apparently that counts as a repo, but yeah. So a lot of it's really interesting to kind of like hop in there and sort of like take a look at the state that like someone left their code in, and then throw humans into it to kind of like figure out what the hell is going on, right? Yeah.
But that messiness is real.
Messiness is real,
right?
Yeah, and it's one of those artifacts that like actually I think is more beneficial than it is. I mean, it's painful to say the least, but like it is a natural representation of what you would expect someone's real development world to be like. And so in that way, I think this subset of the private is extremely valuable.
Yeah.
Yeah. And I think at the end of the day, if human feedback is the ultimate eval, right? Like real developers coding using Cursor or Cloud Code or whatever, you need to make sure that the environments that they're interacting with do actually capture that messiness, that nuance, because that's what they're going to be asking models to operate on.
Right.
And they're going to expect that these models, in a world in which we actually think they're capable enough of, doing larger, more complex tasks, they're going to expect these models to, find the right solution or be able to answer questions about the code base. And so even though it is a little counterintuitive to the idea of having like very clean, very structured, organized data, I think it is net good to kind of introduce this distribution into the mix.
Yeah.
Yeah.
I have more anecdotal things here.
Go
on
for
private.
it. Yeah.
Great. So as I think Jeff mentioned earlier, there was part of the problem that we produce is the environment. It's that like coding environment that the agents will then inhabit when they try to solve these problems. And those need to be produced somehow. We have teams of humans who are doing that, and that's a large part of the stuff that went into SWE-Bench Pro. But we've also tried throwing agents into the mix to try and do this. And this is totally like non-quantitative, but we've seen a radically different performance when we throw them into, say, a public repository compared to when we throw them into these private held out ones. So much to the point where like we actually can't use them these agents in the private repositories. And so their function is exclusively in the in the public ones. Of course, if you want like more quantitative evaluations of this, I'd say read the paper. But yeah, you can leave that here.
That's crazy. So like in our own work producing this benchmark, we've leveraged agents to help along with the process of producing the data.
Correct.
And in doing so, we've observed that the agents are way more effective
Yes.
in the open source repos than the ones that we've sourced from private code bases.
Yeah.
That's that almost tells the story for us, but that's great. Okay, so maybe let's just like dive straight into the benchmark. So tell me a bit more about like how we made the benchmark and like what goes into making a good SWE-Bench Pro task.
Yeah, so in SWE-Bench Pro, we kind of defined a formula or defined a framework for this benchmark that's a little bit different. So in SWE-Bench, you have a problem statement, which is the PR. So yeah, it tells you, okay, I have this bug or this feature I want to implement, and then maybe a couple of steps on how or like what's the issue. Then in SWE-Bench Pro, we introduced two new fields, the requirements and the interface. So the requirements are a little bit more explicit. So we would have a list of tasks that the agent would have to solve. So these might be a bit closer to what actually would need to be done. Maybe if, for example, you had a tech lead who was trying to help you spec out your task, this might be what you would get from them. Then we have the interface, which is just a little bit more help for the agent. So in the cases that, I guess like what we saw was that often models will just forget to name a class or forget part of the implementation. So we redefine it in the interface. So we explicitly lay out what the model needs. And then we test in kind of like both of these settings, like with and without the requirements and interface. Then for SWE-Bench Pro, we have the environments as Edwin discussed. So these environments for SWE-Bench Pro are Docker images and enable the agents to use tools, and then also enable us to test the agent at the end. So test the patch. And then all in all, it kind of creates this end-to-end problem where you have the problem statement, requirements, interface, the environment, and then also a set of tests that we use to define if the agent was successful or not. So these tests are hidden when the agent attempts the task, and then we use them to evaluate the agent. So these tests would often be produced by humans, and then we select the ones that are needed to pass the tests or needed to solve the problem statement.
So this is interesting. I'm wondering if you guys can kind of dive a bit deeper here. So I think similar to SWE-Bench, right? So SWE-Bench Pro relies upon unit tests as our verifiers, right? And so I think one of the interesting things about SWE-Bench Pro is that our task distribution looks slightly different. So whereas I think, in SWE-Bench Verified, many of the tasks were related to bugs, like bug fixes. With SWE-Bench Pro, we have a more diverse distribution where there's, I think, I don't know, maybe it's like 30% bug fixes, something like that, 40. But we also have like new features.
Yes.
And then we have optimizations or enhancements. And so I'm curious, like specifically for new features, how do unit tests work for new features, and like what role do the requirements and interfaces play in that? Edwin, any thoughts?
Yeah. I think we tried to keep as natural of a distribution as possible to reflect what humans were actually doing in GitHub at such and such time. So we don't touch the unit tests. The implication of this is that if the unit test requires a specific name or module to exist or something, then like that requirement or interface needs to be present in that problem statement. And so this is an explicit design choice we've made in order to capture the distribution of like what new features people are testing for, whilst also allowing the models to have enough context to even begin to attempt them. What we don't want to do is be artificially hard, as in like pose problems that are just like dead on arrival. Like there's no way anyone could have guessed this or like,
Right.
And so in that way, it's like sort of our happy medium of how to provide just the right amount of context to solve the problem, whilst also being fair in the actual grading of the end result.
So like an example of this might be, let's say the problem statement is, it would be great if this library had some logging feature.
Right.
And in the unit test that accompanies that PR, that commit, it tests the capabilities of this, or the functionality of this logging feature, but like it might assume a specific class name,
Correct.
right? And so you can imagine that like, if you just took the prompt by itself, a coding agent could come up with dozens of equally valid solutions, right? Each of them with different names.
Yes.
But they might fail this unit test because it wasn't named the specific thing the unit test is expecting, right? And so part of, I think, what these human augmentations do is that like it gives the model just enough information so it can narrow its solution space such that any viable solution in that solution space will actually pass the verifier and would be considered correct. Is that sort of, am I tracking that correctly?
Yeah. And it's not isolated to just like the name of modules. It could be the existence of a submodule or like some sort of like assumption on the like split of how the feature ought to be built.
The exact like error string.
Right. That's the worst one. Yeah. Is when someone hard codes exact error strings, which does happen. So I think a lot of this is, I mean, we've iterated over this a lot. And I think each time we're almost like uniquely surprised at how many different ways people have tried to sort of capture the functionality of a new feature via unit tests. And so we keep having to adjust that. And this is our way of doing that.
So I guess like another way that we could have approached this, right, is like we just rewrote the unit tests. And that's pretty complicated, I think, for a number of reasons. But like I'm curious, like, what's your take on that approach?
Rewriting the unit tests. Yeah. I think it's valid. Like we've attempted that too in other areas where we have done unit test adjustments. It's often hard to capture the original intent or maybe like project out what should or shouldn't have been caught. And even if you do that, I think you're still gonna succumb to like, I still need to name this module something.
Right, exactly.
So, like that requirement is still gonna be there. And so if faced with the choice of like, I could write more unit tests, sure. But like, I'm still gonna have the same, that doesn't solve for like the problems that we identified earlier.
There aren't going to be these like unit tests that are just universal verifiers for every valid solution in a solution space. So you're always going to have some narrowing.
Exactly.
What we need is your browser agent to go and verify exactly what the output looks like.
Awesome. I'm curious, like, which of those like key failure modes do you think is like the most ripe for advancement in the near term? Like, what do models need to improve at to do better at this benchmark?
The instruction following in the long context, like I think that would be solved really fast because there's such obvious mistakes that the models are making. It's kind of like how like 6 months to a year ago, like the models were also has the type of like instruction following issue or just like weren't as high quality, and then now they just make fewer mistakes. They need less human intervention, and that pattern would just continue. Then afterwards, the last two are a little bit more difficult to solve. For capabilities, I think, as the models get larger and then, kind of solve this like end-to-end RL training loop, then the capabilities of the model will get better. Probably be the last thing to solve.
I'm curious, like, how does performance change, like, as a function of task complexity? Like, I'm thinking, like, number of lines added, like, files touched, like, are there any discernible trends?
Yeah, I think for the number of lines, we don't have any PRs with less than 10 lines. And then for 11 to 20, which is the smallest set, models can get about 50% to 60%.
50 to 60? Oh.
Yeah, so all pretty good, I think. Maybe like check the paper for the real number. And then beyond that, like 30 plus. So we have like 30 to 40. And then we also have 50 plus, so very challenging ones. So for 30 to 40, they might get closer to 20 or 25%. And then for the very challenging set, maybe the big changes, very few models get those correct, and some models don't get any correct. So maybe like 10%.
So kind of a steep drop off from there.
Yeah, exactly.
Interesting. Cool. Well, I think that's pretty interesting insights. Anything else that you guys want to call out? Final takeaways?
It's been a pleasure making it. I think there's a lot more that we want to do in this space of coding agents for sure. As we kind of mentioned earlier, like we're still following very closely to what you would see in like a SWE-Bench verified setup, introducing a couple columns, but like largely the same structure.
Mm-hmm.
This thread of like, let's get better and more closely aligned to what humans actually are using in the real space of developing software, it's a through line that's like going to continue for a while.
Yeah.
And so like really not too much more to say about SWE-Bench Pro, but plenty to say about what we're going afterwards.
Cool. So maybe that's a good place to end it. So I want to talk a bit about like where things are going from here. So I'm like curious, like the types of coding problems that labs are actually training on. Like, what's the direction of travel for that? Like, what is it? SWE-Bench style tasks. Like, what's the next generation look like?
Yeah, one is longer horizon tasks. So that's kind of what we're getting at with SWE-Bench Pro. More realistic, more challenging, and then also on the edge of what humans can solve. So what would take a human maybe 6 hours to a day. Then also more diverse types of coding problems. So something like Cursor, it not only needs to be able to solve the patch, it has to be able to answer your questions about a code base, maybe solve a security issue, or improve performance or optimization. So I think we touched on that a little bit with SWE-Bench, but yeah, like these more realistic Cursor style use cases where the coding agent needs to be able to do a very wide variety of tasks.
And so is that something we're covering in SWE-Bench Pro, or something we're actively researching for the next release?
Actively researching.
Okay, so stay tuned.
Stay tuned.
Very cool. Yeah, I'm particularly excited on how we can innovate on verifiers. I think, we've used unit tests for far too long. And, like you said, a lot of coding work, is not necessarily tied to code patches. It's not necessarily, confined to developing within a repository, but it could be, answering questions, right? It could be evaluating like the process or the style of the code. And so I think, I'm personally very excited about how we can add, these sort of verifiers and introduce newer rewards to coding agents. Cool. I know we are running low on time right now. I think the last question that I want to ask is, like, where do you see coding agents going in the next 6 to 12 months? So obviously we established that right now engineers are fine, we're safe, but I think given, your thesis on how rapidly, we think labs might be able to hill climb on SWE-Bench Pro, or, all the new research that we're doing around new types of verifiers, different types of prompts that are more aligned with real world use cases. Where do you see the space in a year from now?
I have kind of a high-minded approach. I love this co-development paradigm.
Mm-hmm.
Like I have a semblance of a plan or idea of where I want to go with something. But through conversation, implementation, adjustment, in conversation with these agents, and then managing that context back and forth, I'm able to sort of like self-discover some new state of the code base that like wasn't really in my purview at the start. And so that's something that like I hope I get even better at, and I'm hoping that as the agents get better too, find new things. Just
I agree. And then I also think the agents will get more autonomous. So we will continue to use them as humans, so we'll continue to use the humans and the agents, but also that the agents can get a little bit more autonomous. So they'll need a bit less of our intervention. So maybe, like in a few months, we'll need like a bit less, and then a bit less. I think that trend will continue.
Cool. My 2 cents, I think we're going to see coding agents that are like continue to generalize in capabilities. So like I think we're already seeing this now, like Cloud Code and Cursor agent mode, you support MCP. And so like, you can imagine coding agents that can sort of run the gamut of like, reading a new feature request on linear, and then like implementing that feature request in the code base.
yes.
And then like using browser agent capabilities to like verify that the new implemented component on a front end actually works. And then like actually reviewing the PR itself, and then like going back to linear and like closing the ticket, like doing this kind of end-to-end development work, to say nothing of DevOps, which we didn't touch on at all. But like I think there's a lot more space for coding agents to like generalize into more horizontal developer responsibilities and capabilities. Cool. Well, with that, I think that wraps up this episode of Chain of Thought. If you have any questions for us, please leave it in the comments, and we will get back to it next week. Thank you.